with your excellent presentation. And the fourth presentation entitled Evaluation of, Improvement of the Thermophysical Comfort with Modified Polymerine Fibers. It is submitted by Professor Dr. Maria José Grande, University of Beira, Technique, Portugal. She has a PhD in Textile Technology in Covilha University. Scientific areas of interest: clothing physiology, comfort, textile physics, spinning. Please, Dr. Maria.
Good afternoon, ladies and gentlemen. And first, I apologize for my English that is not very good, but I try to do my best. The scientific area of my presentation is clothing physiology, and I will talk about comfort, how to improve comfort, and about the new textile materials. But first, I would like to show you my country, Portugal, my city, Covilha, and my university. And by the way, as you can see, it's possible to arrive there by plane. About comfort, we know that actually to feel well inside garments is becoming more and more important, and comfort is one of the major aspects to be considered when buying or wearing a specific piece of cloth. In 1997, it was being done an inquiry, and the question is, can you sacrifice comfort to the fashion? Well, as you can see in the picture, 67% of persons said, I want comfort, and just 33% of persons say, I prefer fashion. Like Pillar did, it's possible to define the clothing physiology as the science that studied the relations between the human body, clothing, and environment. And actually, it's possible to talk about science and engineering of the comfort. Why? We see that that four different sciences have present: physics, physiology, neurophysiology, and psychology. And together, they gave us the knowledge and understanding of clothing comfort. This way, it's possible to talk in comfort science. About the thermophysiological comfort, it is defined by two important properties: the mass transfer and heat transfer. About mass transfer, we need to have good properties of suction water and vapor water suction. About heat transfer, we need to have appropriate values to the principal thermal properties: thermal resistance, thermal absorptivity, and thermal conductivity. And as we can see in the picture, only is possible to talk in thermal comfort when we have high values to the thermal resistance and low values to the absorptivity and thermal conductivity. Is also possible to define two different thermophysiological comfort, the static and the dynamic. The static is when the temperature is near the skin is between 31 and 32 Celsius degree, and the moisture is less than 60%. The dynamic when the temperature near the skin is between 33 and 34 Celsius degree, and the moisture less than 17%. After this, the question is, how is possible to maximize the thermophysiological comfort? Two ways: through optimized functional knit stretches and through new textile materials. What is a functional knit structures? A functional knit structure is a knit structure with at least two layers with different textile materials. As we can see in the picture, we have the layer number 1 with hydrophilic material, and which name is the absorption layer and is the outside layer. Layer number 2 is the inside layer, which name is separation layer and is made with hydrophobic material. In this case, we have a polypropylene filament. This kind of structures give us a permanent dry contact between the skin and the textile structure. So, what we pretend to do now is to optimize this kind of functional knit structures. How? Through the development of structures with suction channel in the separation layer and through the optimization of the structure composition. We pretend the determination of the ideal percentage of the hydrophobic component in the separation layer. In this slide, we can see what is a suction channel. We have two different representations. And what is a suction channel? Suction channel is I would like for him to I don't have. We have number 1, the absorption layer. Number 2, the separation layer. And number 3, the suction channel. So, a suction channel is a yarn of cotton that sometimes goes to the separation layer to suck moisture from the skin. We have the suction channel from cotton, and here the separation layer from, in this case, polypropylene. To optimize the number of these kind of channels, we studied the variation of the principal thermal properties with the number of channels, and we obtained these results for thermal resistance, these results for absorptivity, and through the optimization curve, we can conclude that the ideal number of these channels it's about 18 channels per square centimeter in the structure. To the optimization of the structure composition, we did the same. We studied the different thermal properties, and we concluded from the results that the ideal value is about 25% of polypropylene in the knit structure. Talking now about the new textiles materials, I want to make reference to a new modified polypropylene fibers represented in this slide, which cross-section is a U, a star with 5 points, and a star with 8 points. U, 5 points, 8 points. With these new filaments, new textile materials, we reproduced the optimized functional knit structures, and we obtained these results. So we can see that is with the star with 8 pounds that the thermal absorptivity is lower, thermal resistance is higher, like thermal conductivity. So it's possible to conclude that the maximization of the thermophysiological comfort properties is possible with modified polypropylene fibers, especially with the star cross section with 8 points. And why? With this section, the space between the filaments is smaller, and so we have very good suction properties of water and water vapor. To analyze, to evaluate all these properties, we used these instruments, Alambeta and Permi test instruments of Professor Lubos, and finally it was possible to conclude that the percentage of the hydrophobic component is very important to the thermophysiological comfort, like the number of the suction channels. And it is with the modified polypropylene fibers that is possible to attain the best thermophysiological comfort properties, as I said before. We did also a subjective evaluation of these structures, and with the scores methods, we found very good correlations between the subjective and experimental results. So it's possible to say that these kind of structures may be designed by high performance functional knit structures. And finally, we have here somebody very happy, and somebody feels well because he's wearing a functional knit sweatshirt, probably made with modified polypropylene. Thank you very much.
Thank you, Dr. Maria, for your very, very interesting presentation.